So a slightly different variation of it, right? We could do what we could do here in this example. We could provide another constructor to the scooter, right? So in the scooter constructor, we could perhaps take parts as parameters, right? So we can say engine, and then we can say wheel 1. Instead, actually, let's say let's use like front, right? And then another one. We can use front and back, right? Front and back, something like this. Okay, and so we can now write our constructor. The second version of the constructor still needs to construct I mean, we can just essentially copy and paste this, right? So we can say engine. This time we're not saying engine equals new engine. Instead, we'll take it from the outside, right? And of course, when something like this happens, we have to say this, right? So just to specify that we're accepting object reference to already existing engine, right? And then we still have to create the array of references to two wheels, but then once again, this will be instead wheel front, right? We're going to capture the front and then back. So that would be another twist in terms of configuring the system. But if that's the case, right, we need to do this stuff, creation of objects. We need to do this somewhere in the client program, right? So we could create engine as basically engine as I should have not erased this, as new engine, and then we could have constructed the wheel, right? We can construct the wheel, wheel front, something like this, new wheel, and then we can construct the wheel back, and also as new, and now we'll get rid of these comments because they're not very very accurate, right? And so finally I will create another scooter, right? Scooter 2, right? And this time I have this constructor where I can provide the engine reference, I can provide the wheel front right here, right? And also the second one, the back, or something like this, right? So this would allow me to basically write a different implementation, but for the same diagram, right? And most likely, or it's kind of likely that I could have another, public, oops, wrong place, somewhere here maybe, just for the sake of demonstration, public static scooter factory, okay, which could take some parameters. And so what it does is does all this, right? So it knows how to construct parts, and then of course it basically constructs a scooter by doing by still using the new, right, because we're in the Java environment, and immediately returning it, right, and so this way I can use this by using the scooter factory, and so that would basically formalize the fact that I create the engine, the two wheels, and then the actual scooter aggregate in the same location. So again, I'm sort of following the idea that the creation time for all of these is the same. So my diamonds essentially carried over here, and they represent the idea of an aggregate object. Basically, in the comments, I could say construct parts, right? Parts, and then construct the aggregate. The aggregate being the object which holds all the parts together, the whole thing, right? Construct and return the aggregate. All right. So that would be the second demonstration of this, of this idea of aggregation and composition. So the true composition is not possible in Java because there is no containment by value, right? So if we have the scooter, it can only hold references to other objects, but it cannot physically contain other objects as values, which would be this situation, and this is possible in a C++ environment where the actual the engine and wheels can be contained directly within the scooter, and so we have predictable sequence of construction of all of these objects, right? So normally when the constructor executes, the contained parts constructors are invoked first, and then the outside object, the outer object constructors are invoked next. The sequence of destructors is exactly the opposite and also predictable.